All right, here's the Unit 4 quiz number 1 solutions. And I hope that this helps you so you can do a requiz. Again, we're either looking for, again, you got to remember odds or evens. Odds are going to look like this. Odds are going to have like up and down squigglies. Evens are either going to be up or down. So we have to decide there. But the thing about evens is they're pointing in the same directions. So we look, this has an odd exponent. So we know it's odd, and it's also positive, which simply means that it's going to look like the squiggle and have that general positive slope going from left to right. So as I go from left to right in this way, right, it's positive, it's going up, so it has a positive, general positive slope to it. This one right here, it's an even, highest degree is even, so that means the arrows are either going to both point up or they're both going to point down. Since this is positive, that means we're going to use the both pointing up. Well, it's a 4th degree, so I probably shouldn't draw too much of a parabola, but whatever. As long as the arrows were pointing in the same direction, I was okay with that. This one is an odd exponent. Again, we're only looking at the exponents. I don't care about this one. I don't care about this one. All I care about is this thing right here. The highest degree is going to be odd, and it's negative. So instead of the normal one, which goes like that, when it's positive, what we're going to be doing is coming down and have like a negative curve that way. Number 4. Number 4 has a positive x squared, or a positive exponent, highest degree. I don't care about these, but a negative leading coefficient. So because it's positive, it's going to be pointing in the same direction, and because it's negative, something like that. Again, it doesn't have to be accurate. This is not at all what this thing looks like, but the end behavior is what I'm looking for. Can you tell me that it's going to be pointing down? All right, so describe the end behavior. You actually have to do more than what you had to do for the first 4. You had to actually think about what this picture looks like. So what's going on here is it looks something like this. Because it's the 5th degree, it's odd, and it's negative, so it's coming down. So as x goes in this direction, what's y doing? Y is going down to negative infinity. So y approaches negative infinity. As the x goes in this direction, what's the y doing? Well, the y is going up. So y is approaching positive infinity. This is an even exponent, so the arrows are pointing in the same direction, and because it's got a positive leading coefficient, they're both pointing up. So I know they're both pointing up. So that means it doesn't matter what direction I go, y is going to be pointing towards positive infinity. And this one is just the opposite. This one is even. So I know they're pointing in the same direction, but in this case, they're both pointing down. So that means no matter which way I go for x, y's will be approaching negative infinity. On the back page. Okay, so this is the squiggle. The arrows are pointing up and the arrows are pointing down. That means that the degree must be odd. And if you look at the general look of this line, it's got a generally it's going up, so that means it has a positive leading coefficient. Okay, since these are both arrows pointing in the same direction, then I know this is going to be even. Since they're both pointing down, that means the leading coefficient has to be negative. This one's pointing in opposite directions, therefore the degree must be odd. And since it's coming down, it's negative. All right, now to the factoring. Factoring shouldn't have been overly difficult. First thing I'm going to look for is a GCF, in this case 4x cubed. When I take 4x cubed out, I'm left with x squared minus 16. And I know I just wrote that down wrong. Let me fix that. X to the 4th minus 16. Well, this is a perfect square, and so is this. So this is, again, the difference of perfect squares. X cubed, x squared, and x squared. One's plus 4, and one's minus 4. Well, I'm not done, because this one can continue to factor, not this one. This one's all set. There is no such thing as the sum of perfect squares, but there is the difference of perfect squares. So this is just x squared plus 4. However, this one, we can continue to factor to x plus 2, x minus 2. That's why that got highlighted. Again, we'll take out a GCF, it's 5, and I'm left with x to the 4th minus 4x minus 5. Well, I can factor that. Oh, squared, because I took out the 5. So 5 x squared and x squared are x to the 4th. And minus 5 is easy. That's just minus 5 and plus 1. Well, I can't do anything more with that. This is not the difference of perfect squares, the sum of perfect squares. And that's nothing. And it didn't ask me to solve it, so I'm finished. And finally, we'll just do a little bit by grouping. We'll group these two together. We'll group these two together. I can take out an x squared here, and I'm left with x minus 6. Take out a minus, copy with a minus. So I'm really taking out a negative 9, because negative 9 goes into both 9 and 54. And I'm left with x minus 6. I just realized that I changed this problem. It doesn't look like I saved it. I changed it here, but I think I printed it before I saved it. So you guys don't have this one. You guys have this being minus 6x plus 24. And I did this in order to, so you wouldn't end up with an x squared minus 4 again. But for some reason, I don't know why you guys have a different copy than I have. But anyway, it's the same work. You're going to take out an x squared. You're left with x minus 6. Copy over this minus. Between these two, let me draw this in a different color. Over here, between these two, I can take out another minus 6. I'm sorry, this is a 4. So let me erase. Let me get rid of all this crap so I can almost start this over again. So this was a minus 4x, apparently. And let me get rid of that. Sorry about this. So I guess apparently it's minus 4x plus 24. So I'm going to take out a minus 4, and I'm left with x minus 6. Okay, that's better. So notice they have the x minus 6 in common. So that's my first set of parentheses, x minus 6. And my second parentheses is x squared minus 4. Well, that can be factored again. Oh, and by the way, they're asking for roots, so we really need to set this equal to 0. So I get x minus 6. And this is x plus 2, x minus 2 equals 0. And then my three roots are very simple. X equals 6, x equals negative 2, x equals positive 2. And you can either list them like that, or you can list them like this. Negative 2, 2, 6. And that's it.